sing a happy song together, and we'll all be a happy family.
Hi, welcome back to the channel. So today, going to look at this little Dansette Popular. And these were very popular record players back in the day. A lot of teenagers, I think, had them to play their pop records on. And I've had this one for many years. But one of the issues with these is that the crystal cartridges, and this one still has the original one, which is now failing quite badly, because the crystal cartridges just do not last for the 60 odd years that have gone by, probably even nearly 70 years by now. So if we want to replace the cartridge with a more recent one, then that's likely to be a ceramic cartridge, and it will work, but a ceramic cartridge puts out a much lower level signal than a crystal cartridge did. So when you change this for a ceramic cartridge, the top volume setting, because you've only got one valve in the amplifier, it won't be very loud. You could listen to it, but it would be on the quiet side, let's say. So the way round it that most people do is to fit a small preamp, and they typically get an IC or something like that, and just fit a small preamp in between. But I've kind of thought to myself, I'm not that keen on that, really. I mean, you need to do something like that because it's the only way to boost the signal. But I thought, I don't really want components that are what I would call an anachronism, things that didn't fit with the time period of this. And I have got loads and loads of ECC 81 valves and things like that, which I could, perhaps make a valve preamp, a simple triode valve preamp that would make this work well with a ceramic cartridge with that little bit more amplification. By adding the extra valve, it would be nice to do it that way, I think, because it would keep it within the realms of the technology of the day this was made. So that's what I'm planning to do, this series of videos. Rather than it being a repair video on this, it's a modify video, how to modify this to take a ceramic cartridge without resorting to fitting modern components. Okay, so let's get this out of the way for now. And I'll zoom in a bit. There we go. So here's the circuit diagram of the Dansette as it is. You can see it's extremely simple, but there's also a worrying feature about this. I'll zoom in a bit more, bring it in a bit closer, I think. There we go. So what we actually have is the mains coming in here, and you see that it's not marked live or neutral, and when that record player was originally marketed, it had an unmarked mains lead that could be plugged in either way round, quite often to a light socket or something like that. So you didn't know which side was going to be live and which side was going to be neutral. And if you look further along, you can see the line going from here, goes along here and to the chassis, which means that the volume control shaft, for example, or tone control shaft, could well have mains voltage on it, depending on which way round the plug is. It could be neutral, it could be live. So that's one thing to worry about, and why I make the caveat that my videos are really only for entertainment. Don't copy what I do. None of this complies with modern safety regs, and just don't play with high voltages unless you already know what you're doing. but don't take it from my videos, please. Look elsewhere for if you need to learn about that first. Now, there is also the possibility, of course, that one side of the pickup is going possibly to live. So you can have live wires actually going down the arm to the pickup cartridge. I find that really very concerning. And I think what I've done, without looking, because it was a few years ago, I think I did put safety capacitors in these lines so that it would at least not connect you directly to the mains. But that's another thing. What we're looking at here today is how to modify this to give us a little bit more gain at the front end using a simple triode valve. So we can see that we have our HT coming in and it's halfway rectified using a UI85. So the mains comes in through here, through the rectifier, and then you've got a smoothing cap there, you've got a resistor, 12k resistor there, and another smoothing cap this side. So that's a standard kind of pi filter that you normally get on Valve HT systems. So basically what we want to do is to introduce the triode amplifier, which will go in front of this. Basically we want to add it in front of this circuit, leaving much of this as it is. We would add our triode circuit here. So let's have a look at what we might do. Bringing this one into play. Okay, a blank sheet of paper, that's always a nice place to start. So let's have a valve. Put a grid in there, anode, cathode, and a filament. So the valve I'm planning to use is ECC 81. ECC 81. That is a 6.3 volt heater valve with two triodes in it, but I'm only going to use one of them. And I also have UCC 85, which could do the same job, but that has a 19 volt 100 milliamp filament. This one has a 6.3 volt 300 milliamp filament. More on that in a minute. But what we're basically planning to do with this circuit to get the amplification, so that's what we've got so far, and then we would put a capacitor in here, probably 0.01. As I say, there might already be capacitors there, and that's your pickup input coming in there. So that's how it looks. Signal comes in through a capacitor, possibly through that resistor. 1 meg to bias the grid there, and the cathode connection to ground with a DC offset provided by this. Now in here we need a load resistor. I would guess probably something like that. Not sure what yet. Now this point has got to be smooth. This is your HT for this valve. This has got to be smooth. So I think I would add in an additional smoothing capacitor there. Let's make that say 22, because I know I've got some 22s that are high voltage. And we would feed that this is going to be extremely low current. It's probably only going to take a milliamp or something. So we can put quite a large resistor in there. Let's go for that. We can always adjust these values afterwards. And then that will connect onto the HT. So let's bring this back up to show it more clearly. We have 100k load resistor. We have 22 microfarad smoothing cap, HT fed from a resistor, which would probably be quite a large one. The main thing we want to do here is to make sure that this point is smooth, gives a smooth HT to this, so we don't introduce too much hum. I'm sure there's bound to be some hum with these circuits, there usually is. Now we've got our output signal coming from here. We can put that through. Again, a capacitor, which we have to do to isolate it from the high voltage, 0.01. And then that, and you've got the chassis here, and that feeds into your input as it was. So effectively that's as if it was the feed direct from the crystal cartridge, which you know this goes off to the volume pot and feeds into the one valve amplifier as before. So that's the kind of setup, roughly drawn, that I would like to introduce, and I reckon that will give me quite a lot of gain. It may actually be reducing the gain a bit, attenuating it down, depending, but that should give me some sort of input that will allow the ceramic cartridge to be used. Now, the issue is not that. That's quite easy in a way to implement. I've got all those components. I've got the valve socket to plug the valve into. I've got all those bits and pieces. So there's no real problem with implementing that. The problem is, as always with valves, you've got to provide filament voltage. And if I use the ECC81, which I'd like to do because I've got quite a few of those, so I certainly found it probably a new old stock valve for that. And we're only using half of it. And because of the way the valve is constructed, you can use the two filaments in it in parallel or in series. So I could either find a way to provide 6.3 volts at 300 milliamps, or I can put the two filaments in series and provide around 12 to 13 volts with a reduced current demand. You know, it would be about, obviously about half, so 150 milliamps, something like that. So yeah, that's the way I can do that. I need either 6.3 volts or let's say around 13 volts. Now if I use this valve, the UCC85, which will work for this, I mean it's not normally used in audio applications, but it would work. Certainly as a small signal amplifier for this. That has a 19 volts, 100 milliamp. That is that one. So yeah, so I've got to find some means of providing filament voltage of either 19, 13 or 6.3 volts approximately. I mean, obviously if I can provide a slightly higher voltage, I can always put dropping resistors in to get the heater filament current correct. But that is the main difficulty I'm going to have, is providing filament voltage. So if we go back to the actual circuit, as we can see, the filament voltages for these, they come from a tapping on the motor winding. This was a way of eliminating the need for an additional coil. You could use the actual motor winding as an auto transformer to give you probably around 38 volts, I think. I haven't measured it, AC. Through these two in series at 100 milliamps, and that's how these filaments are provided. So if I were to put the UCC 85 filament in series with that, that would reduce the voltage across these, and they wouldn't work properly really, because they'd be underpowered. I can't change this tapping as far as I know. I think that's going to be something that I wouldn't want to mess around there. It might affect the performance of the motor and all sorts of things. So what I probably have to do, I think, would be to introduce a small transformer which will go really basically across here, across the mains line coming in, to drop my voltage to the 6.3, 13-ish or 19 volts. So if I look in my junk box and I can find a small, I don't want a great big huge transformer, it hasn't got to supply a lot of current, but if I can find a small transformer that gives me one of those 3 voltage levels or around that, then I can go from there. I'll have a filament voltage and I can decide whether to use the ECC 81 or the UCC 85 as my triode input. So that's where we are at the moment, and my next thing is going to be to rummage around in the junk box and wherever I can think of looking to see if I can find any sort of transformer that will provide those voltages. I would have thought somewhere I'm going to have something that will do the job. So that's it for now, but if you've got any thoughts, of course you're always welcome to make constructive comments about this and perhaps why it may not work. I think also that even if I didn't change the cartridge, the failing crystal cartridge would be amplified by this, and that might be enough to keep it in service a bit longer with the original cartridge. But I certainly would now have the option of changing to a ceramic. Well, so we'll catch you in the next one, and bye for now. Thanks for watching.
Sing a happy song together, and we'll all be a happy family.